Okay, so here is our video on the graph of y equals tan x. We've looked at sin x, we've looked at cos x, and this graph of tan x is in degrees, but you have to be comfortable in dealing with it in radians also. Beginning to sound like a broken record. Okay, so can anybody give me important information about this graph of y equals tan x? Any information at all? There are vertical asymptotes. Okay, so we've looked and we've talked about asymptotes before. What are asymptotes? Should put vertical. What are asymptotes? Yep, the graph tends to a certain number. Does it ever reach it? No, it doesn't. So we've got vertical asymptotes here. I've drawn them in the green dashed line at 90 degrees and at 270 degrees. So they occur, so from 90 degrees, the asymptotes occur every 180 degrees, okay? So they're going to happen every 180 degrees. Okay? Right. So our graph, y equals tan x, as it gets closer to 90, the graph keeps increasing, okay? It keeps getting higher and higher. It never actually reaches it. Let's actually quickly go to Desmos. Okay, so here is our graph, and let's zoom out a little. So we can see here is our 90, okay, and our graph is getting closer and closer and closer to 90. Can you all see this okay? Good, excellent. And it's getting closer and closer to 90 degrees, but it's not actually touching it, okay? And that's the same in the as it approaches 90 degrees from the other side as well, okay? Is that okay? Okay, good. So what can you tell me that, what can I say cos of 90 is then? If, yeah, if it's an asymptote, then it's undefined. It's not actually going to exist. Who said that, by the way? Good man, Sam. All right, so I can put that in here, okay? So let's scroll down a little. Cos of 90 is undefined, and just to show that it's undefined, we will put a dash. And we said cos of 270, also undefined. What is 90 degrees, Darius, in radians? Pi over 2, good. And 270 degrees, Jaden, in radians? 3 pi over 2, good. Let's just quickly put in the rest. 360 is 2 pi. 180 is pi. 60 is pi over 45 is pi over 30 degrees is pi over 6. Okay. What is tan of 0 degrees? Here's 0 degrees. Tan of 0 is 0. What is tan of 180 degrees? 0 as well. It's crossing at 0. What is tan of 360 degrees? 0. Right, and then these ones are our exact values in which we use our triangles. You all used your triangles yesterday for those questions. So I've got 60, 1, 2, root 3. Tan of 60, opposite over adjacent, root 3. Tan of 30, opposite over adjacent, so 1 over root 3. And tan of 45? Tan of 45 is? I'm sure you're all telling me the answer, you're just all on mute. 1, thank you. Okay, so tan of 45 is 1. So these values you have to know, okay? You have to be aware of all these values. Sorry, just taking a drink of tea. All right, well, let's keep having another look at this graph, see if there's anything else. Does it have a maximum point, like the sine and cos? It doesn't. It doesn't. It starts at 0 and increases up towards the asymptote and comes back up again here. What is the period of this graph? So when does it start repeating? Yes, so it starts repeating. So think here is going up. Where does that start to happen again? It starts to happen again here. Okay, so it is, the period is 180 degrees or pi radians. Good. Make sense so far? Good. All right, let's look at some. Okay, so if you've got this in a non-calculator paper, the first thing you would have to do is draw yourself out a sketch of tanx. So I'm going to actually draw it as opposed to using the Desmos one because I want us to get into the habit of drawing. So the first asymptote occurs at how many degrees? 90, and then it comes up like this. It crosses at 180, and I've got another asymptote, and that's at 270. And then the graph comes back up. Wow. And it is a sketch, it's not a work of art. Okay, so it looks something like that. Okay, and this is, I expect you to be able to draw these. You must draw these in the exam if you're trying to work out the exact value of, should actually say tan 330. All right, so tan of 330. 330 degrees is in between 270 and 360. So, first question, Frankie, is it going to give me a negative answer or a positive answer? Negative, because it's going to correspond to this value over here. And let's look, so here's 360. This is kind of a nice starting point, but actually, somebody tell me how you want to work this out. Let's have one of the SL students. And I will pause record. So, Jin, do you want to go from 270 to 330 or from 330 to 360? Or do you want to do both or do you want to do something else? Okay, so you went from 330 to 360. How many degrees is that? 30-degree difference. Okay, and that is from this point. Okay, now where is the other landmark that looks like this? It is right here. So I have to go 30 degrees back, which is going to bring me to 150, right? So that's telling us, sorry, I haven't really drawn this very well at all, because that's supposed to interact with that one. But this is telling us that tan 330 is the same as tan of 150, right? And so we're getting closer. Now, is it 30 degrees? Because we went 30 degrees from 180 and 30 degrees from 360. We were using these landmarks, so we can't. Yep. And if you use the landmark of 0, you're going to end up going back 30 degrees over here somewhere. You're on the right track. Right, okay, good. Because 270 to 330 is actually 60 degrees, yeah. So I could go 60 degrees forward here. And from this point, I would go how many back? Back 60, right. So back 60 to 30, and that's going to give me, yep, and it's going to give me a positive or negative answer. Yeah, but with tan of 30, is tan of 30 going to give me positive or negative? Yeah, it's going to give me a positive. So to account for that, I have to make it negative, right? So, what is tan of 30? Yep, root 3 over 3, or negative 1 over root 3. And just to double check this, 1 over root 3. Yeah, we're looking good. Okay. Now, so that's one possible way. Let me scratch this and redo it out again, maybe a bit neater. And maybe have a look at another way. Okay, let's try and make this neat. Okay, so it's a bit neater. 360, 180, 270, 90, and let's just quickly look again. 330 is going to be in here. It's going to correspond to this particular value. So we looked at going from 360. Probably the easier way is to go from 270. Actually, the easier way to be go from 180, because if you look at the start of this graph here, this landmark at 0 is the same as from 180. Okay? So probably a nicer way is just to start from 180. How far is 330 from 180? 150? Yeah, that makes sense, obviously. So if I start from 0, from this landmark, because these are both the same, go out to 150. Okay, that's giving me exactly the same value. Now this value is how many from 90 in this direction? Yep, 60. And so to find the corresponding value, I need to go back 60 and take the negative of it. Is that okay? Yep. Okay. And it's exactly the same process, you know, for the other ones, just like what we did for sine and cos. You're just kind of looking at these landmarks. I like that a lot. I'm going to pass that off as my own. Do you want to try one yourselves? And if you all get it right, then I'll let you go. Oh yeah, and you answered that question, don't you? All right, find the exact value. Starting with 330 was actually more difficult than it was probably one of the harder ones. So this one should be actually be easier. Find the exact value of tan. Let's see. There's only so many of these you can actually ask as well. This should be nice and easy. 225. And I want you to privately message me your answer on chat. And I want an exact value, so no decimals. Okay, on chat, please.